Second to last video of this lesson, and this is the last one that you should watch if you are having problems with understanding the lesson. But comparing graphs and tables is what we're looking at. So this is video number 3, comparing graphs and tables. So I put a little bit more context into this problem. This problem is one that rings a little bit more true to my current life. So as of right now, my dad, as he's gotten older, has started to travel much slower via car. In other words, he essentially gets nervous behind the wheel. He used to be a great, fantastic driver going the speed limit and all that jazz. But in his years that he has continued to live over the last about 10 years or so, he's gotten a little slower. Substantially slower, we should say. When it comes down to it, like he will drive 15 miles an hour down Main Street instead of the 25, or he will, when he gets on the interstate, he tends to go about 60 miles an hour instead of, Montana has a pretty liberal speed limit. So I can understand why he doesn't necessarily want to go like 75 on the interstate or 80, but he goes 60. He gets nervous behind the wheel. That being said, my husband has a little bit more of a lead foot and tends to go more the speed limit. We have often gone on little family road trips, and my dad just knows that because of how he drives and how fast he goes, he will tend to get places 2 or 3 hours behind us, and that's just how it goes. So this is an example of one of those situations. Because my dad tends to drive slower, he also tends to go on frontage roads, which doesn't help anything. We try to go on interstates just so that way we can get there and we can actually start having fun. Having kids in the car, it makes it a little difficult. Either way, we have this situation. My dad drives via this table. So this is my dad's driving. And when he drives, after an hour, he drives 45 miles. After 2 hours, 90. 3 hours, 135, and etc. If we look at this one, this is my husband driving. And when he drives, we can see that after 1 hour, he's gone about 75 miles. After 2 hours, he's gone 150. After 3 hours, we have this coordinate point 3, 225. So after 3 hours, he's essentially covered the same distance that my dad has covered in 5. So let's look at these two situations in the same context. We can either turn both of these situations into equations. We can turn them both into tables. We can turn them both into graphs. Doesn't matter what you want to do. It's just important that you can compare. In this situation, since I have this coordinate point here and I have this table here, and it's important that we practice turning things into equations, I'm going to turn this table into an equation, and I'm going to turn this graph into an equation. I need to go sit down, and I'll be right with you in 2 minutes. All right, so let's look at this table, and let's turn it into an equation. That means I need to find the slope, increasing by 45, increasing by 45, increasing by 1, increasing by 1. I can see that holds true for the entire table. And this over here, I can look at that afterwards. Actually, I should focus. All right, so let's create an equation to just with this. Y equals mx plus b. My slope, 45 over 1, or 45 is there. Now I need to use this slope to work backwards to find my y-intercept. My y-intercept is when x is equal to 0. So that means I'm subtracting 1. So if I subtract 1 over here, I need to subtract 45. 45 minus 45 is 0. So we have the same y-intercept as I have here. So 0. Y equals 45x plus 0. If I look at this graph now, I can now focus on that. I have 2 points. I have this one at 0, 0, where I'm starting, and this one at 3, 225, so I can use my slope equation. Our slope equation is that y2 minus y1 over x2 minus x1. I can also look at this in terms of how much is my rise versus how much is my run, and I can look at it like that. If I look at this, I'm going to use this as my second point, so that means this is my y2, 225, minus 0 over 3 would be my x2 minus 0, and I get 225 over 3, or 75. So my slope here with this equation, y equals mx plus b, is y equals 75x. My y-intercept is 0 plus 0. So if we look at these two situations, we can see my dad, he drives substantially slower, 30 miles per hour slower than my husband does on the same road. We have the same y-intercept. We start from the same place. But again, like I said, my dad travels a lot slower, so his rate of change is a lot less steep. So if I were to even graph this, I would have a graph that looks something like this and have a line that's even like a lot less steep. So comparing table to graph, I turn them both into equations so I could compare them thoroughly and actually look at the y-intercepts and the slopes being different. Thanks for watching. Thanks for all the bearing with me with all the different distractions. I appreciate you. There's one more video after this where we're going to look at all three equations, tables, and graphs all at once. And we're going to look at how those can be compared in one final scenario. It is a bonus one, so you don't have to watch, but either way, you're welcome to. Thank you for watching, and I will see you maybe in the next video. Bye. Yeah.